Let's talk about the camera. You know, that little device you carry around in your pocket every single day. Well, its story is a whole lot longer and weirder than you might think. We're going to trace its history back 2,500 years, from a simple, strange discovery all the way to the supercomputer you use to take selfies. And no, that's not a trick question. Seriously, what could your phone possibly have in common with a dark room from ancient history? Well, the answer connects the oldest principles of optics to the picture you took of your lunch yesterday. It all boils down to one simple thing: capturing light. And the whole story of the camera is really the story of us teaching light how to leave a memory behind. Okay, so here's how we're going to break this amazing journey down. First up, we'll look at a room that could literally see. Then, we'll dive into the chemistry that taught light to remember things. After that, we'll see how we finally put the user in control, how light itself turned into pure data, and last, we'll meet the mind-blowing AI that's running the show inside your camera right now.
That's right. The very first camera wasn't a gadget you could build or buy. It wasn't an invention at all. It was an observation. Just a moment where someone realized that light, all on its own, knows how to paint a perfect picture of the world. You just have to give it the right space to do it.
This wasn't just one person either. Thinkers from Mozi in ancient China all the way to Aristotle in Greece noticed this really bizarre effect. Picture this. You're in a pitch-black room, but there's one tiny pinhole in the wall. You look at the wall opposite that hole, and somehow a living, moving, full-color image of the outside world appears there. The only catch? It's completely upside down. It's kind of like magic. Later on, artists like Leonardo da Vinci actually built these dark chambers to help them trace scenes with perfect perspective. So, what's the crazy science behind this? Well, here's the thing. It's shockingly simple. There are no lenses, no mirrors, nothing fancy. It's just geometry. See, light travels in straight lines. So the rays of light bouncing off the top of a tree outside go through the hole and hit the bottom of the wall inside. And the rays from the bottom of the tree, they go through and hit the top. And boom, that's it. That's all it takes to make an image.
Okay, but here was the one huge, maddening problem. This amazing image was basically a ghost. It was a phantom that only existed in that present moment. You could see it, which was incredible, but you couldn't touch it, you couldn't keep it. The second the sun went down, poof, it was gone forever. And that single frustrating challenge is what drove the next couple thousand years of innovation.
So to make that ghost permanent, to make that image stick around, optics just wasn't going to cut it. The next giant leap forward had to come from a totally different field. The answer wasn't in physics anymore. It was hiding in the world of chemistry. So, flash forward to 1826. A French inventor named Joseph Nicephore Niepce, he finally cracked the code. He used a metal plate coated in, of all things, a kind of asphalt that got hard when sunlight hit it. After an exposure that took over 8 hours, can you imagine? He captured the world's very first photograph. Just a few years later, a guy named Louis Daguerre made the process way better, creating these incredibly sharp images called daguerreotypes. But even then, you had to sit perfectly still for minutes at a time, sometimes with hidden metal braces holding your head in place. I mean, just stop and think about what this really means. For the very first time in all of human history, a moment in time could be grabbed right out of the air and made permanent. Light itself was physically carving a memory into an object. This wasn't just a new gadget, it was a completely new way of looking at time itself. So how did this chemical magic actually work? Well, the secret sauce was a type of chemical called a silver halide. The easiest way to think about it is to imagine the surface of the film is covered in billions of microscopic, light-activated switches. When a single particle of light, a photon, hits one of these switches, it flips it on, creating a tiny speck of silver. Billions of these flip switches create an invisible pattern, a latent image, that's just waiting to be revealed in the darkroom. Okay, so we figured out how to trap an image. Awesome! But just being able to trap it wasn't really enough, was it? The next big hurdle was figuring out how to control it. How do you turn this messy, complicated science experiment into a tool that an artist can actually use to create something beautiful? And this is where we get something that every photographer knows and loves: the exposure triangle. All of a sudden, photographers had these 3 powerful levers to become the masters of light. You had aperture, which controlled how much light got in. You had shutter speed, which controlled how long that light could hit the film. And you had ISO, which decided how sensitive the film was to all that light. Learning the dance between these 3 is what lets a photographer go from just taking a snapshot to creating a masterpiece. Now, having all that creative control was huge, but let's be honest, photography was still for serious experts. It meant lugging around heavy gear and fragile glass plates. It was anything but accessible for the average person. But the revolution that put a camera into literally everyone's hands, that came from one visionary guy, George Eastman.
Eastman's idea was just pure genius. First, he invented flexible roll film, which immediately got rid of those heavy, clunky glass plates. But his real magic was the business model he built around this perfect slogan. You'd buy a simple little Kodak box camera. Once you'd taken all the pictures, you didn't take the film somewhere to get developed. No, you mailed the entire camera back to the factory. They did everything else and sent you back your prints, along with your camera, all loaded up with a fresh roll of film. It was brilliant. And just like that, anyone could be a photographer.
Okay, so now pretty much everyone has a camera. What's the next big thing? Well, color, of course. We wanted to capture the world as we actually saw it. And the way they figured it out is so cool. They basically just copied the human eye. See, your eye uses 3 different kinds of cone cells to see color. One for red, one for green, and one for blue. So what did early color film do? The exact same thing. It used 3 different layers of chemicals, with each layer sensitive to, you guessed it, red, green, and blue light. Chemistry was now mimicking biology to paint the world.
For more than 100 years, photography was chemistry. It was all about dark rooms, silver, dyes, and smelly developing baths. But the next revolution, the one that really defines our world today, it threw all of that right out the window. Light wasn't going to be captured by chemicals anymore. It was about to learn a whole new language, binary.
It all kicked off back in 1969 at Bell Labs with something called the Charge-Coupled Device, or CCD. This was the first real digital sensor. Instead of a chemical reaction, it used a grid of tiny light-sensitive squares made of silicon. And here's the magic trick. For the first time ever, a beam of light could be turned directly into a stream of electricity, the native language of computers.
So here's how it works in simple terms. Think of the sensor as a giant grid with millions of tiny buckets on it. When light hits one of those buckets, a pixel, it starts to fill up with an electrical charge. A really bright spot in the scene means that bucket gets filled up a lot. A dark spot means the bucket is almost empty. The camera then just goes through and measures the exact charge in every single one of those millions of buckets, turns each measurement into a number, and a tiny computer uses that huge grid of numbers to build your picture. And you have to understand, this was a massive change in thinking. A photograph was no longer a physical thing. It wasn't a piece of paper you could hold in your hand. It had become abstract, weightless. It was now pure information, a stream of ones and zeros that you could copy 1,000,000 times without losing any quality and send around the entire world in an instant. Which brings us right back to today, and to that phone in your hand. We've journeyed from optics to chemistry to digital hardware. But the final, and honestly the most mind-blowing leap in the camera's story, it isn't about the hardware at all anymore. It's all about the software. That tiny lens on the back of your phone, it's not just a lens. It's the eye of a computational beast. The moment you tap that button, it's not just taking one picture. It's secretly capturing a dozen or more shots at once, analyzing all of them, and then using crazy techniques like image stacking to intelligently merge the best parts of each frame into one final image that's way better than any single one could ever be. You know that beautiful, blurry background in portrait mode? That's not a fancy lens doing that. That's an AI building a 3D map of the scene in real time to figure out what to blur. It's just insane. The amount of processing going on is just staggering. We're talking billions of calculations, merging data, correcting colors, getting rid of noise, mapping out depth, and it all happens in the fraction of a second before the picture even shows up on your screen. What it means is that today, photography is basically applied rocket science disguised as a simple little button. But you know what's truly amazing? After this entire 2,500-year journey from a dark room in ancient Greece to an artificial intelligence in your pocket, the camera is still fundamentally answering the exact same simple question it was at the very beginning. What did the light look like right here at this very moment? So the next time you pull out your phone to take a picture, just for a second, remember that whole journey. You're not just pressing a button. You are holding the final result of a quest that took thousands of years to complete. And it was all in service of one magical goal: to pause the physics of the universe and hold a little piece of it in your hand.